All right, starting up again. Um, done typing for the day. Done typing for the day. Done typing. So, I'm gonna do some more ML stuff. Um, Something interesting I want to explore is the updating algorithm that we came up with. So, the LMS rule here, right? So we get theta j. I'm gonna put a prime there, is equal to the original theta j, where theta is the parameter here, plus, what's it, the learning rate, the training rate, times the value for the particular sample, because I is the sample, or the particular point, say, minus the hypothesis function, theta of the input for that point times xji. So xji here is, so I is all the samples. What? So j here is the particular vector component. Okay. Okay, I see. I see here. So we update theta. Um, we say theta plus um, the difference between the actual value for the sample itself minus the predicted value for it times the for the sample what that component is for it. Okay. So if the sample is very, very high, if xi is very, very high, that means that the sample is very, very high. Sorry, the component of the vector for that sample is very, very high. So you want to update it fairly quickly for small changes, from what I can tell. Okay. Then here, yeah, so we got the locally weighted stuff here. Yeah, there's some probability stuff which does matter. So then we get the logistic request. This is like really important, I think, if I'm recalling this correctly. So I'm gonna spend a lot of time just like thinking about this, making sure I like fully understand it. Like I know this is like in theory not that hard to do, um, but like I haven't done real math in such a long ass time. So um, I do want to get good at this stuff, and this does seem like a lot, but I want to do it. It's gonna be fucking difficult though. Okay. So we get the logistic equation. Um, so g of z is the logistic function. So g of z is a logistic function, and of course, this makes sense for um, flattening things to be 0 or 1, or be between 0 or 1. So the question is for it, um, what's the best way for us to train for it? So if we have a bunch of samples, right, how do we do the training for the samples? I know I didn't get very far on this last time. I know this is a little bit pathetic, but whatever, man. I like my software. I like my machine learning, and I'm gonna keep on doing my machine learning. Okay. So, so the negative first for it. So what's the sample space here? So the sample space is we have what's it, yi? Is that what it is here? What's the so y here? Yeah, it's either 0 or 1. Yeah. Yeah, so we have a bunch of yi's here. Okay. So you have a bunch of yi's here. So yi is like a space. It's a set. I mean, it's not exactly a set. It's a so we have a mapping. We have the mapping from. So let me step back a bit. What is the hypothesis function here? What's it take in? What's it output? It outputs a real number. That real number is between 0 and 1. The input for it is a vector of some kind. Okay. So x here is a series of vectors. Okay. So the probability. So the we want to maximize. We want to find the most props. So given a certain hypothesis, we want to figure out, given a certain hypothesis and a certain data, right? The hypothesis outputs the probability for each data set. We want it to be the highest probable output for a particular data set, if that makes sense. Hope it does. So, if we do that, um, yeah, so the probability of, I'm just writing this down myself. So the probability of the y vector, I'd prefer Einstein notation for this. There isn't a good way to do that. It's the probability of yi given a particular x I. I'm going to make sure it's clear that that's a vector. It's a set of vector. No, it's just a vector. Comma theta. Is theta j? Yeah, so theta here should be a vector in itself too. Okay. Yeah. So that is equal to yeah, so it was that one right there. So that's equal to the oh yeah. Why did that was so silly before. h of theta of x I. I wish I had a pen that could change colors easily. Not really. Times 1 minus the hypothesis of theta. So yesterday I was just breathing through the mouth and I wasn't actually thinking about it. And I know I should be thinking about these things more because then, like, in order to learn, you have to think. You can't just breeze through it. Okay, so that all makes sense to me. So then what? So we have to multiply by pi I. So we get pi of I equals 1 of, I'll put that in there, h theta of x I. Okay. 1 minus h theta of x I. I like to know when my vectors are vectors. I like to know when my notation. Then we take the ln of that. So that becomes the sum of, so I is equal to 1 to n here, the sum of the log of, and I'm just going to log h. I should put parentheses there. H0. Make sure it's clear. H0 is a vector of x theta I. Um, plus log. I guess I didn't need the brackets there. Plus log of 1 minus h theta I. Okay. And now we want to do gradient descent. Is gradient descent really the fastest like algorithm we have for this kind of shit? Like, I feel like there's got to be a better way. I'm sure there's a fuck ton of research on that. There's a fuck ton of research on anything in machine learning, honestly. So we gotta get the derivatives of this shit. Because we need to. Yeah, yeah. So then for a particular theta. Yeah. Good. So then there was the sum again. I is equal to 1 to n of log. I'm just expanding it out. Logarithm of 1 plus exp of theta j. I should use the notation they use for it, which I know, like, is silly, but I could use Einstein notation. That'd be fine too. It's not really Einstein notation, but it is Einstein notation. Okay, plus log of 1 minus that's still a negative first. Don't want to forget that, because that's important. 1 minus 1 plus exp theta t x I yeah, negative first. So then that one flips over, right? So then that becomes plus log of one plus exp of negative. Am I forgetting my negatives? I was forgetting my negatives before. Okay. Yeah. That one should be actually positive, so that one's a theta t x like I negative first the log of something into negative first. We can just pull that out, can't we? Well, I haven't even taken the derivative yet. But I should do this for funsies. For funsies, oh my god. So it's actually minus here. Log of 1 plus exp to the theta t x theta I and another person to ban because they're a fucking bot. Okay. Okay. So we take the derivative of this whole thing here with respect to theta j. Yeah, because we're varying with respect to theta j. What's the theorem for Newton's gradient descent shit? What's the theorem for that again? I forget. Okay, so get the sum I is equal to 1 n. We pass the, and then we do the d theta j, d theta j, uh, so you pull the inside out, and then we keep the 1 over, right? Am I remembering that right? Oh, we could just choose g there, couldn't we? Or I could have used g there. Do I want to use g here? I don't know if I do. Wait, hold up. Do I? So G is H. You know what? Sure. Um, I forget my negative ones there. Yeah, I forgot my negative. No, I didn't. Okay, so we could just put this as log of the sigmoid function of guess yeah, theta t x I plus log of 1 minus g theta t x I. Okay, we take the derivative with respect to theta j. So we still retain the sum, though. We should retain the sum, right? We do the chain rule thing. So we get the chain rule. Why am I always forgetting this kind of shit? It's f g. Sorry, f of g of x goes to, we pull g prime of x out times f prime of g of x. Am I remembering the chain rule right? God, I know this is such basic shit. I know this is basic shit. Yeah, I am remembering it right. Okay. We take the derivative of this thing right here. D d theta j of g theta t xi k. Then we divide this by g of theta t xi. We do the same thing here, plus d d theta j of g theta t xi. It's 1 minus, actually, over 1 minus g theta t x I there. So you get that interesting thing going. Okay, that's cool. Yeah. What? I missed a Y here for some reason. Hold up. Where did I miss my Y? I missed some Y's, some big Y's. Oh. So, Christ. Yeah, so I missed. So, yi. The second one is 1 minus yi. I. I. 1 minus yi. Yeah. Y. I. So 1 minus yi. Yeah, that propagates down. And then that would propagate down too, but we don't need to worry about that right now. Okay. So I guess that makes sense. It does make sense. Okay. Yes, you take the derivative. You pull the yi down. Hold up. it's not. It's when you take the log. Put the yi down. Okay. Damn it. Well, okay. This actually goes here. Then let's just rewrite it if I need to rewrite it. Yes, I do have that right. I wish there was a better way to like write math notes. There's gotta be someone who's done good software for this. Like, I want to be able to write out things on my notepad and have it just bang onto the page and not have to worry about it at all. So, let's do the sum of I equals 1 to n yi dd theta. Okay, so it is right about that. You can pull shit out. So you get yi, yeah, time g theta to the negative first. Theta t x I to the negative first minus 1 minus yi of one minus yi of, yeah, 1 minus g theta. Don't you? Okay, good dog. I, that, that's to the negative first also. Yeah, and then all of that gets times by the, yeah, t d theta j g theta t x I there. Yeah. Okay. Okay. Cool beans. He added a comment on midnight? Okay. So what's the point of that? Is it just to do the derivative on the outside? Yeah, it is just to do the derivative stuff on the outside. Which is silly. Hold up. So we know that the derivative of, oh, wait, hold up. That's something we proved before. Yeah, the derivative of the sigmoid function is the sigmoid function times 1 minus the sigmoid function. Which intuitively makes sense, because like as the output for the sigmoid function gets greater, um, like the closer it gets to 1, you want it to like decrease, and the closer it gets to like 0, I mean, it also should decrease as it gets closer to 0. So both of those make sense. Outside of the bounds, I wonder what that diff EQ solves to. But I don't know that. So, I don't know. We'll figure it out. America. Why is it unlisted? What the fuck? Why is it unlisted? No. Jesus Christ. No, it's public. Save. Save. Everything needs to be made public. Jesus Christ. Do I have to go back to my old streams too? And make them public? Why are they all unlisted? What the fuck? Public. Publish. Public. Publish. Public. Public. Publish. Public. Publish. Public. Publish. Public. Publish. Publish. Public. Jesus Christ, why is it all... Why was it going unlisted? What the fuck? The default should be public. The YouTube just was like, no. Dude, fuck you, man. Fuck you, YouTube. Jesus Christ. My lord. Okay. Okay. So, what do we pull out of this again? So we get the sigmoid function that gets pulled out there. Okay, so then what we end up with after we pull out the sigmoid function. So d theta t of x. Yeah, that does turn into xj. Yeah, it turns into xj. Yeah. Okay. So we end up with 1 minus. So we end up with y times 1 minus the sigmoid of the thing. 1 minus y times the sigmoid of the thing. So in other words, we get the derivative of the log likelihood is y minus the hypothesis of x here times xj. So we get d theta j L of theta is equal to that. So it's the same, which is interesting. Okay. So now we get to the logistic loss thing here. So logistic loss, okay, is L log. I should write this down just for like muscle memory shit. T comma y is equal to y log 1 plus exp of negative t plus 1 minus y of 1 plus exp of t. Okay. That's interesting. What's that look like? So it's a sum of it. I want to see what this looks like visualized. L. Learning with humans. Yeah. Okay. Give me 1 sec. So it's like given a y, given the t for it. So what does the t tell us then? Can you tell me a bit more about this logistic loss function? I'm gonna ask Jippity it. Can you tell me a bit more about this loss function? Logistical loss. Chat Jippity. Oh, nope. Oh god, I did that all wrong. Can you tell bit? Almost did it. Almost did what I shouldn't have done. What's this? What? Okay, so if y is equal to 1, interesting, interesting, interesting. Ooh ah, yeah, ooh ah, yeah. I guess. Okay. Okay, I have penalties for disagreeing. So as it gets higher. Oh, okay. I see, I see. That's interesting. Okay. So what does this tell us here? Does this give us anything interesting? I don't follow. Wait, what? That doesn't make sense. Why would it? Wait, what? 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 What the fuck? That just doesn't. Oh, DT. Oh, okay. Oh, no, that's not DT. Oh, it's just a shorthand way of getting to it. I see. Holy shit. I practically just burnt myself. Okay. So much peanut butter on this. Too much peanut butter on these. Okay. So then it goes to the perceptron stuff. And then after this is the next one where it talks about okay, this is interesting. Another algorithm for maximizing the probability shit. It's a neat trick though. The log of multiplication of things. Hmm. Hmm. That's interesting. It's quite interesting. Yeah. Huh. That's cool. Hmm. I don't know. Interesting. Interesting. That's cool. Is that the right one? I thought it didn't jump to. Am I misremembering this? I thought it. I thought it went to softmax. Oh, sorry, it did. I just skipped over it because I'm a big dummy. So softmax does something similar here. So softmax. Yeah. Yeah. Okay. Um, hold up. So a loss function is, in this case, this is cool. It's L of theta is equal to sum of n equals 1 to n with negative log of exp of, so it's, where's the yi coming from here? That's just pi, right? It must be a copy paste error. T of I. Wait, no, it's not. Is it? Wait, what? Oh, it's not. It's not. Holy shit. Okay. That's interesting. Over T of J theta J T of xi. Holy shit, machine learning is cool as fuck, man. Do I have this right? So yi is the nth. So wait. So. Yeah. So okay. Hold up. Let me make sure I'm understanding this right. So the loss function is negative log of uh what's the log? It looks like that. So why is it okay? Okay. It's odd, but okay. Um, of theta. Hold up, hold up. So T1. Hold up. So for a particular x, where x are the input vectors, it's n input vector. so x is an input vector. Jesus. Is that a sum over all points? Is that a sum over all points? No, it's a overall dimensions? I guess it's overall dimensions. Okay. So it's a sum over all dimensions. Normalized by no, that can't be it. So xi is a particular point. Xi is a particular point. But then what is yi? Yi, I guess, is the true. Oh, it's the true value. Okay. So it's the true one we should be using. Okay, okay. So then it's the exponential of the true choice over the sum of the exponentials of everything else. Okay, okay. So that goes from 0 to 1. Okay, so that goes to 0 to 1. Um, if it approaches 0, it goes to infinity. If it approaches like 1, it goes to 0. Oh, wait, no. If it approaches 1, it goes to wait. Yeah, no. This makes sense. So if it approaches 0, it goes to infinity. If it approaches 1, it goes to 0. I see. Visualizing math, right? Like this is something that like I should have done more when I was like learning about mathematics. I was just like, I'll just grind out the calculations. That's easy enough for me. But I never really learned the visualization as much as I really feel like I should have. You know? Um, okay. Um, and this is for all points. Yeah. Yeah, baby. Yeah, baby. Okay, cool. This is like so straightforward and also at the same time not at all. Okay. Okay. Get it again. So the chain rule thingy is oh, that's why. Well, kind of yeah, cause this one is the this is like the derivative right there, right? Yeah. Oh, minimize it. Well, it does make just sense at a high level. Um, yeah. So we want to minimize it. Yeah. The loss function here. Okay. Huh. Uh, so that's for example. Oh, that's interesting. Yeah, it does it for each individual one. That's cool. That's cool. I should implement this. I should implement these. Okay. Huh. They're just weights. They're just nodes in a network. Okay, so this is cool. This is really cool, actually. Um, that doesn't make sense to me. Exactly. I don't have enough time to think about that, though. Am I logging off for today? I might. So this is really interesting. So this thing right here, right? It says just logistic regression. That's very cool. There's so much that you could just expand outwards just from that. Okay. So what is generative learning here? So that's 34. Cool. I'm done for the